Hi, this is a recorded of our ZP Developer Zone webinar. So we like to do this live every Thursday at 8 a.m. London time, but we have had some internet issues this week. So unfortunately, now I'm recording it, having tried to live stream it, and unfortunately it is a day late, but let me go ahead anyway. So we do have a ZP Developer Zone. We have the ZP Academy. This is an online resource with free materials. We do the webinars every Thursday, so many questions are actually quite nuanced, so we have to kind of hold these webinars in order to answer nuanced questions. We have collaborations, jobs, and we have the website itself, and we have workshops. So for example, if people are interested in wearable sensors and continuous glucose sensors, for example CGM, then we do have a workshop taking place on the 14th and 15th of September in Norway, and I'll put a link underneath this video afterwards. Also, I want to just discuss that this week we're going to talk about pH sensors, glycine detection, electrolyte measurements, and I'm also going to talk about microneedles and glucose strip CGM. So let me dive in a little bit more. We were asked, do you have a data sheet on the low-cost pH sensors? I will address that now. They need dimensions, information, and response times, etc. And then more questions. You know, what's the volume of the flow cell for online use? So, mechanical dimensions. There were two pH sensors on the website. It's actually the one on the right-hand side that I'm recommending. This one with a rectangular electrode. The dimensions are actually there. The physical dimensions are there, but that's the gross dimensions. They're actually on that website. But at the same time, if you're looking for a data sheet that's representative of this, then there's another. There is a data sheet on the website, and I've put a link here. So I'll put a link underneath the video. If you're looking for dimensions of this pH sensor on all the dimensions, then there is a data sheet that's representative of it, and I'll put a link underneath this video as well, so you can have a look at that. Response time was one of your questions. Response time, so obviously on the website under the underneath pH sensors, we do have under that URL pH sensors, we do have a lot of data. So the reason I bring that up is because response time is really dependent on what pH you're going from to where. So let me just illustrate that a little bit. That you can see here that we go from pH 7.39 to pH 10. You know, that response time is actually quite long, and sometimes when you're in a lab using a pH sensor, you'll notice that it takes a long time for the pH sensor to settle. Whereas I would say it was much quicker when we went from pH 10 here up to about pH 4 here. The response time to sort of reach some of these plateaus was much quicker. So unfortunately, when you're the response time of a pH sensor is partly linked to the pH sensor, partly linked to the solution, partly linked to the pHs of those solutions. So you really have to sort of try it and see, I think, is the short answer there. In terms of flow cell volume, yeah, we have some flow cells on our websites, and I've found some links to it, and you can find out that it's about 160 microliters in the flow cell, so about 160 microliters. And again, any links, I'll put them underneath the video. Anyway, so the next question really is regarding glycine sensors. So we've had an inquiry. It's a sort of industrial type application. It's quite a dirty environment. These people would like to monitor glycine. Obviously, we have a lot of off-the-shelf sensors. I'm not suggesting that glycerol is glycine. You know, I know the difference between obviously glycerol and glycine, but looking at this and then talking to our engineers, you know, we thought no, we definitely can do we can definitely do a glycine sensor, and so, but the question really is what form factor to do it in. We have a form factor underneath the OmniSense. The OmniSense is probably the best, lowest cost form factor to do this, where you essentially have a, and I'll go backwards a bit, you have a sensor that we can put into a meter. So our sensors are often kind of look like glucose strips. So you have a glycine sensor that goes into the meter. The sample goes onto the meter. The app development is very straightforward for us. So the app resides on an Android, because Androids are generally lower cost, which is probably good in a ruggedized environment, because if you break it, you can replace it fairly well, unlike iPhones. Anyway, the app will run the meter. The meter will get the glycine raw signal back, and we upload it to our database, and that from there we get the concentration, for example, in ppm. I put ppm, parts per million, because in engineering they often use ppm, but the units are not so, let's say, so critical. So let me back up a little bit and just say that we think the glycine sensor is well within our wheelhouse. We have some handles on it, especially as we have something similar molecule, but we have glycerol. We're enough of chemists and electrochemists to know we can do glycine, and then it's really just a form factor. The easiest way of doing it, and therefore the lowest cost, is actually just to do it through a handheld device like this, which is really akin to a glucose meter. But it's really critical that we send the data to the cloud, and then we turn it from there into concentration per ppm, and that's our OmniSense product line. I don't think this is what the client is looking for, but we could also do glycine sensing in a as kind of in situ form factor, where you kind of have the sensor in a rod, and it makes, again, Bluetooth connectivity. In this case, a base station, and from there we go up to Julie, and we can send the data then to an app. So we could have something that was kind of more in situ continuous monitoring, but I really think that feels like we're opening up a whole raft of difficulties in that application. So I'm not really super keen to do that, but we can end up even doing a mesh network where you're actually measuring glycine in several places, and they're all talking to the base station, sending the data to the cloud. But as I said earlier on, my recommendation really is at least do the handheld device first, because it will be a lot easier to do. It's easier to do discrete single measurements than to try and do continuous time course measurements. So rather than our sort of mesh network, I would go for our handheld OmniSense technology. These rods, we do have these rods. They look like this. And this will give you a sense of actually the scale on these rods as well. I will go on a little bit. So question number 3 was about electrolytes. So at Zimmer & Peacock, we do have a number of electrolytes. Today we can do pH. The proton in there is an electrolyte, let's say. But we have pH, chloride, potassium, calcium, sodium. Now, we understand that obviously when people ask us about electrolytes, what they're really asking us about, in some ways, is some form of the sort of comprehensive metabolic panel, this CMP. And so under the CMP, we have, at the moment, at Zimmer & Peacock, if we look at the CMP, the sensors that we have in houses, we do have a glucose sensor, we do have a calcium sensor, we do have a sodium sensor, we do have a potassium sensor. We don't have a carbon dioxide sensor, but I'm pretty sure we can do it. We do have a chloride sensor. We don't have albumin, but I think I know how to do it, or I do know how to do it. Alkaline phosphatase and alanine transaminase. Again, we don't have these, but we could do them. Same with aspartate aminotransferase. These are basically enzyme reactions, and so we're pretty good at these. Bilirubin, it's not on the web store, but we have done it as a team. Blood urea, nitrogen, again, we'd have to develop it. Creatinine, we have done several versions of creatinine, though they're not on the web store. So with this entire list, the techniques, the electrochemical techniques that we would use would either be voltammetry, amperometry, or potentiometry. And I think it's really important to understand that you can do all of these tests on an electronic set this is my finger, so this is much smaller than the, let's say, my fingernail, or it's smaller than my fingernail. So I just want to be clear that it's really important when people are developing both sensors and electronics that they get the right mindset, that the electronics for running these tests should not be large, and it could be as ridiculously small as my finger here. And the way we do our firmware as well, we'll be able to do all the sensor types off an electronic set like this. Now back to the question itself. So My advice is start simple. Don't start on something like the potassium sensor. I'd actually say start on the pH sensor. And I have a recommendation on the pH sensor, which is these sort of hyper value pH sensors, and I've put a link here. And we do have a set of electronics that's also low cost as well. I think they're about €250 for just one board, which really saves thousands of, not thousands, but yeah, hundreds of engineering hours. You'll find that we have all the description of how to communicate with the board on our website, and we have an OEM solution. So just to back up a little bit, if you're interested in blood electrolytes, that's completely fine. If I was to start an engineering project around it, I'd actually go for pH, because when you're doing the electrolytes for pH, you're really doing the electronics for all the other electrolytes that we also mentioned as well. So when you're doing the electronics for pH, you can also be at least thinking about potassium and sodium at the same time as well, and chloride and calcium as well. So you can work on pH, but actually you're secretly doing potassium and sodium and the other electrolytes at the same time. And we do have an OEM electronic solution for that. Question number 5. The questioner was interested in gold microneedles, the holder, and they also wanted to know about could they reuse these gold electrodes. So let me jump into it. So my recommendation is this. We have this piece on our website. Thankfully, I have linked to it here. It has a reference electrode on it, and it has some gold pads. I would recommend using it with. In fact, what I'm doing here is just showing you where to go and find this. There's a drop-down menu here, and you'll just find some gold electrodes. So go to this page, drop down here, and you should be able to find it. I am recommending that you get what we call the Sensit Smart wearable kit. It'll just, because when you're in an R&D phase, you do not need electronics that are sort of very engineering heavy. You basically need good software, and I think the Sensit Smart is the best. In this particular case, is the best option for it, and that can also be got off our website as well. So I'll just back up slightly. So I think this is quite a straightforward inquiry in some ways, which is you can get the gold array electrodes off the drop-down menu. I would use it in conjunction with this Sensit Smart kit. There's a cable that comes with it. I think that's just the best way of kind of R&D'ing a wearable based on that gold microarray. Now I think, because you want to reuse, you're doing science, right? So you're going to break things. So I think actually you shouldn't be working on those gold microneedles, because it'll be an expensive platform to make mistakes upon. My recommendation is you can also use this off that Sensit Smart as well. Is go for one of these. Just go for these guys, because you can do your functionalization and your breaking of materials on something that's much lower cost. So don't do your R&D on I would get a gold microneedle array, because it'll give you a sense of scale and handleability and all that kind of stuff. But for the science, when you're trying to do formulation development, I would definitely do it on a kind of screen printed electrode format, just because it'll be too expensive to make mistakes, on the gold array. So that would be my recommendation there. Question number 6. The inquirer is really interested in understanding how we can supply them with a glucose strip and a CGM. So obviously, glucose strips are sort of discrete measurements of blood glucose, and CGM is continuous glucose monitoring. I'm only going to answer question number 1 at the moment, because I think realistically, the kind of difference in effort between making a glucose strip and a CGM it's almost an order of magnitude these days. It's so much easier to do a glucose strip than it is to do a CGM. So with these kind of inquiries, we do understand very clearly that actually there's a big desire, and a lot of these inquiries actually do come from India. I mean, the population is going to be 1.6 billion. There is a large, we understand, type 1, type 2 diabetes population in India. But we do understand as well that there's a very much a political drive from the Indian government, to have a sort of made in India policy and a made in India glucose strip policy as well. And so at Zimmer and Peacock, our intention actually is to manufacture for the Indian market as an OEM supplier. So what we mean by that is essentially just kind of, sometimes you might call it white label, that we might do some of the manufacturing. Well, we'll do the manufacturing in India, but we do understand that we're going to have to basically label these up for the particular clients. So we don't have any issues with the idea that it'll have to be made in India, it'll have to be low cost. We do understand that people will want their own logos on these things, which is completely fine. And now what we're intending to be doing is actually a glucose meter that can sort of plug into a smartphone, and I mean in the first instance probably an Android as well. And so the glucose strip goes in the meter, and the meter then plugs into the phone, and that gives us great connectivity. So with us it's always a sort of glucose to API policy. So what we're saying is we're probably able to provide all the technology stack from glucose strip to glucose meter to an app. Now in the longer run we can then brand those apps to be client specific, but the apps will then allow the data to go to the cloud, and from the cloud then, using an API, people can bring the data into their own dashboards and start doing their kind of their own AI on the data. So at Zimmer Peacock, we understand that this particular inquiry was about strips and CGM. Now the workflow from going from sensor to cloud is the same whether it's a strip or CGM, and that's why I say focus on the strip, because CGM, I mean if we look at an example would be BioLink in San Diego. In order to make a CGM product, they have been around for about 7 to 8 years, and they've just brought on $100 million worth of investment. So, I mean, if I look at Abbott, the Abbott Freestyle Libre, they have spent millions and millions getting to where they are today. So Zimmer and Peacock, we can accelerate people down that route. But before we start getting to CGM projects with people, we want to see, I think it's worth starting off something that's more achievable in the shorter term, which is the strip, the blood glucose strip, or the SMBG, the self-monitoring blood glucose route. Now, it's probably worth saying that the API at ZP is already in place, that we do have an API feature, and we do have API commands so people can basically get data from us and move it to their cloud. So what we're doing is a glucose to API developers kit, where we'll put glucose strips in there. In the first instance, they will be branded as ZP. An app which will run the meter. Well, you put the glucose strip in the meter runs the strip. The app sends the data to our cloud, and then you'll be able to pull. And then you'll be able to pull the data across to your cloud. So we do have a glucose to API developers kit, and that's really the starting point for anyone who, if your question is, what's it going to cost the ZP to work with me on blood glucose, then the quick answer is you need to be getting into our glucose to API developers kit and get into our program. Finally, I'm just going to do a quick summary of the questions this week. So we had a question around pH sensors. So with the pH sensors, I have a data sheet on the website, and there is a link down below. The volume of that flow cell was 160 microliters, and you saw that the response times were a little bit dependent from which pH to which pH you were going, and that's why it's such a nuanced answer. So the real answer is, and I gave it, is you really have to buy them and try them. Now with the glycine detection, my answer to this one is I think our OmniSense platform will do this. If doing discrete measurements is okay for you, then I think the OmniSense platform is okay. For electrolyte measurements, use the pH sensor as a surrogate, for example, for potassium, and use that OEM board. I think the whole package, I believe will cost under $600, which is a very low cost way of getting going. On those microneedles, yes, we do have the microneedle array on the website, and I am suggesting that Sensit Smart starter kit, but I'm also suggesting, look, you're going to make some mistakes. I'd get some glucose, some SPs, sorry, some screen printed gold electrodes as well, just to allow you to make mistakes and not for it to cost a fortune, let's say. And then finally on the glucose strip CGM in India, then we do have a glucose to API developer kit, and I think that will be the sort of starting point for that. So my apologies that this didn't go live, and in fact we've done it, essentially as a recorded video. It's not my style, but we've just been having some terrible internet problems starting in the street, and unfortunately, therefore, if it's broken in the street, it doesn't work in the house. Okay, my apologies, but we'll try and do this again live next Thursday at 8 AM London time. Okay, thanks very much.